DevOps Iterations.
And here we are, iteration number 9 with Raphaël Pinson. Raphaël, first of all, how are you and what you are doing in these days?
Hi. I'm doing well. I'm okay. What am I doing? I'm currently working as a TME, so technical marketing engineer for Isovalent, so now Cisco. Working on labs, on Cilium, Tetragon, eBPF.
So that's your main focus now, eBPF, Cilium, and the whole Kubernetes world.
Yes.
So Cilium is I would say, probably the most used network interface in Kubernetes world. I'm correct in saying that?
Well, I don't know if most used at this point. It's definitely the de facto standard now. There's lots of CNI plugins. So in Kubernetes, there's no standard implementation for networking, but there's a standard interface, which is CNI. And there's lots of different plugins that have existed. And Cilium is actually the only one that is graduated with the CNCF. All the others are either incubating or they're not part of CNCF. So it makes it the de facto standard now. Now it's used a lot as well because a lot of main cloud providers have used it. So for example, Google GKE Data Plane V2 is based on Cilium. Azure has a default option now to install with Cilium on AKS. And there's lots of other providers like Alibaba uses Cilium. Lots of distributions use Cilium by default now.
But correct me if I'm wrong, it's also something more than a CNI only, no? It does a lot of stuff, Cilium in some way.
Yeah. So the main goal is really implementing CNI. So the connectivity between the nodes, between the pods, and so on. That's the basic goal of a CNI. But it also allows to replace kubeproxy. So to implement the layer 3, layer 4 load balancing inside the cluster instead of using kubeproxy, which typically uses IP tables or another form of net filter. And it also has layer 7 capabilities. So typically it provides Envoy on every node, and it can route directly into Envoy using eBPF, meaning that you can actually implement ingress, an ingress controller, or gateway API, or even advanced features like cluster mesh, mutual authentication, and so on. So it does much more than just basic connectivity.
And it's based on eBPF, so kernel level, fast and furious, so to say. How do you think? I mean, eBPF is probably a sort of revolution in the kernel world, no? Maybe it's at the level of C groups, I would say. Maybe, I mean, it allows to do a lot of stuff and many different things. According to you, are there? Have you explored all the possibilities of the things that we can do with eBPF?
No,
there is more.
No. There is more. There's definitely more. I mean, the whole idea of eBPF is treating the kernel like a collection of events, of hooks that you can plug into and extend. In a way, I like to think that it will take us in a direction that many years ago we were thinking, we should move towards more of a microkernel approach, right? And there's been a lot of things, in the GNU herd project, around L4 Pistachio and GNU Mac and all this stuff. I haven't touched this in 20 years, but this could be a way actually to relieve some of the hard-coded logic in Linux and actually replace it with bits that are more dynamic, that can be more adapted to the workloads and to what you're doing. So Cilium is doing this for networking by typically sometimes bypassing the TCP/IP stack to be more adapted to containers. You can do this for networking. This is what Tetragon does, for example. But there's been some really interesting projects to, for example, improve database performance by working at the device level with eBPF, for example, implementing retries on disk directly in the kernel at the driver level, so that you don't have to implement it in user space, and then you can gain some performance there. So there's still a lot of things that can be done.
Yeah, crazy things, I guess. No, because once you give developers the ability to do things, any kind of things will be done. So, Raphael, we have a common past in the Puppet community and in Puppet world, and I guess you are no more following anymore the Puppet ecosystem. But anyway, what's your opinion about Puppet today? What kind of is still relevant? Is still useful? Is still something worth using?
Well, I don't use it anymore, and that's because I don't manage production, right? I still think it's a great tool. I still think if I had to manage production at this point, I would probably use a tool like Puppet or Puppet itself. I really like Puppet because of the DSL approach. I like that it's a good balance between the flexibility of being able to write modules and making the modules idempotent, and then having a declarative language on top of it. That ensures that you put these idempotent pieces together, you get something that is purely declarative and idempotent. So I still think it's a great tool. I think from a development point of view, it's kind of a generally solved problem, though. I mean, you know how it is, right? In the industry, especially in config management, you know, this. I don't know if you remember this talk by Adam Jacob, the creative chef, was the clock, right? That showed the different stages of automation, going from a script to a framework to a DSL to a manifest like JSON, YAML, you name it, and then back to a script, and we go like this, right? And it's like this in the generally in automation with things like what you can think of, you know, making scripts, and then you go to Puppet to Chef to you go through all the stages, Ansible, and you went all the way around with YAML. But we do the same in Kubernetes and pretty much everything. And so I think at large in automation and platform engineering generally, we're still going through the same stages, and we can still learn from what Puppet has done and a lot of other projects have done. So I would still use Puppet this day because I think it's really cool.
If you have to manage all the legacy systems. And
I don't know if I would say legacy. You know, I think of database, for example, and I have regular conversations with people in the Kubernetes spaces, all this tooling and operators to manage databases in Kubernetes. I would typically use Puppet for this. I don't see a benefit in having a database in Kubernetes. So if I had a production database to manage, I would probably build like some kind of PostgreSQL cluster with Puppet.
On virtual machines or physically.
Yeah.
So you are of the school that Kubernetes is fitting for the right thing, but don't overuse it for things that it is not made for.
Well, not just Kubernetes, but containers in general. I think there's benefits to containers, right? You can easily replace workloads. You can easily roll back and so on. You can do a lot of things that are very useful, especially for stateless workloads. But a lot of the benefits you get from containers are not very useful for stateful workloads, and especially databases. I don't want to roll back my database like this, you know? It's pretty dangerous, actually. So databases are typically the kind of workloads that have a long life cycle and that I want to control. I don't see the benefit in an immutable approach to databases. It doesn't make sense to me.
Yeah, that's a point. So in terms of, let's say, modern infrastructures, I guess you have a good vision of the market and what is happening around and how much different solutions are used. What do you see around? What are the... I mean, we all know what is around, more or less, but, you know, some insights or opinions on...
In terms of what?
In terms of infrastructures, IT infrastructures, so the serverless, Kubernetes-based, let's say, normal virtual physical servers, first of all, how frequently you find companies, places where basically there is a mix of the technologies? And so maybe you have Kubernetes clusters along with virtual machines, maybe even physical servers, maybe some cloud-based service. Is that a normal, or what you see around in this game?
Well, I don't do a lot of consulting anymore these days, but I think, well, I still think the main problem in this field is not the technology itself; it's humans, right? And sure, you got to mix up technology for historical reasons. There's stick depth. There's lots of things linked to technology itself. But there's also the fact that as long as you have different teams with different choices and different views and different focuses, they're going to choose different technology. And so you'll have a mix because of this. So I think it's very often still very much a DevOps problem of how do we choose a technology that is common. And that's why I remember a colleague of mine that I think you know actually from years ago, when Docker came out, and we were not convinced about Docker at first. We were like, well, we don't need this, right? And then he said, we went to a conference. I don't remember if it was FOSDEM and he said, well, there's one thing you can say about Docker is it's not technical. It's the fact that you have people on both sides, from the platform and the development side, that agree on using it, that agree that this is the right interface. And I think the same has been happening with Kubernetes, where it's not perfect. It's bloated in many times, but you have people on both sides of the equation that have agreed that this is a proper interface for what they're doing and a proper abstraction for everything you want to do in the data center. Because Kubernetes is not just orchestrating containers. It's doing a lot more than this. And I think what's really interesting when it comes to automation and cloud and all this stuff and platform engineering in general is that Kubernetes has come as not just an orchestration platform, but like an orchestration API that pretty much provides everything that private clouds had promised years ago, right? And now, you're talking about the state of the industry, obviously. I'm guessing you're also thinking about the state of like VMware and things like this, and how many companies are rethinking their virtualization platform because of the recent purchase of VMware by Broadcom, for example. And obviously, a lot of people in the past have tried to go towards OpenStack. There's other solutions for a private cloud. I think Kubernetes is interesting in this scope. It's not made to manage VMs, but it provides an abstraction, provides an API that could be used for this. We've played quite a bit recently with Kubernetes, for example, which allows to manage VMs in Kubernetes. You can think, well, manage VMs in Kubernetes, that's a bit crazy, right? but actually it just provides a control plane, right? It just uses Kubernetes resources to control VMs that are started using libvirt. So it replaces something like OpenStack with an API that's already here. So I think that's where this is going. Some kind of convergence where it looks like Kubernetes is becoming the standard de facto standard, where you have this API that is here. It can be used for containers. It can be used maybe for VMs. It can be used maybe even to orchestrate cloud resources using things like crossplane and so on. So it's kind of convergence that I think is really interesting.
Yeah, Nigel Kerstein in a previous episode described Kubernetes as a runtime, which actually makes sense because on top of it you do whatever you want. So talking about Kubernetes, you mentioned it's a blog. What are your opinions? What can be done better in Kubernetes? What could be improved?
Oh, well, that's a hard question. I mean, Kubernetes is one of the most contributed projects in the history of open source. There's a lot that has been done, and there's a lot of things that I don't know about, right? When I go to KubeCon, I realize just how many projects are running on Kubernetes, and not even just CNCF projects. There's like 30 plus CNCF projects that I haven't tried. I haven't tried all of them, plus all the stuff that can be done on top. So I don't know what could be done better in the Kubernetes world. That's a really big question. I don't have an answer for that.
This proliferation of operators, plugins, components, which I guess is what makes Kubernetes, the runtime able to also to run, for example, virtual machines with KubeVirt and so on. But do you see some problems in that, some potential issues? Have you tried to use, let's say, third-party components and maybe found yourself, oh, come on, this is not doing the thing I want to do, or in the way I want to do, or maybe it's not doing in maintaining the promises because it's a third-party thing which is not so supported or whatever?
I don't think so. I think Kubernetes is an ecosystem. Cloud native at large is an ecosystem. There's lots of experiments going on, lots of people trying things. And then as people try things, like very often in ecosystems, and especially in open source ecosystem, at this point, Kubernetes is almost comparable to the Linux ecosystem in some ways, right? Where you've got the kernel and you've got lots of libraries, and then there's lots of different distributions that are opinionated. And you can take Linux and you can build your own tool chain and you can choose your own tools and make your own distribution from scratch. Or you can pick something that is already made for you, like Ubuntu or Red Hat, and then you take all the opinionated choices that have been made by someone else. Or there's like frameworks in between, something like Gentoo or Arch, and you have the tools to build exactly what you want without the complexity of doing it yourself. And you find the exact same kind of thing in Kubernetes today, right? You can build Kubernetes from scratch. Hardly anyone does this. You can take a distribution that is already made, like EKS, AKS, or OpenShift, or you can have tools like I don't have one off the top of my head, but I talked to a developer of one recently. Tools that allow you to build your own thing with plugins, right? And choose, oh, I want Argo CD, I want this, I want that, and you build your own distribution. I think this is where we're at this point. There's a lot of things that can be done. And what's exciting is that as we see the ecosystem evolve, there's also people that are consolidating this. They're like, hey, we've tried this, we've tried that. It makes sense. Let's put it in the core. Let's make the core evolve. This is the case with ingress controllers, for example, right? If you've used ingress controllers, so the first iteration of layer 7 routing in Kubernetes, the abstraction was there, but it was too simplistic. And so you ended up with lots of ingress controllers implementation that had tons of annotations or even made their own resource types because they didn't have the abstraction they needed. And so the second iteration has come, which is Gateway API, and it has most of the abstractions that were required by these providers. And maybe there'll be a third abstraction yet coming, and the maturity of the core resources and the core operators are evolving as the ecosystem is experimenting, and then it gets consolidated. I think that's a normal way of functioning. And you know that the operators that you choose today may not be alive tomorrow because it might have been consolidated, or maybe there'll be choices made at the core that will change the fact that you need this plugin anymore. But I think it still makes sense, and it goes in all directions because we're trying to solve a lot of problems with this.
Yeah, and can we say Kubernetes is now mature enough as a project to?
Oh yeah,
definitely.
I mean, if it's not mature enough, I don't know when it will be.
Right, indeed. It's version 1, no more beta. This is fine. In terms of Cilium, let's talk about a bit Cilium. First of all, what is the current version of Cilium? What is the plan?
The most recent release is 1.16, and 1.17 is around the corner.
Okay, and what are the plans for the future evolution of the tool?
What are the plans? There's lots of things, right? One thing that was recently added in Cilium is Netkit. That's super exciting. And this, I mean, surprisingly, there's some people using it in production. Actually, ByteDance uses it in production. So ByteDance is a company that makes TikTok. Mm-hmm. And they actually patched the kernel to use it. This is a bit crazy. The whole idea of Netkit is pushing the limits still of performance in container networking. So this is a big thing under the hood. Cilium has tried to push the limitations of performance when it comes to containers. There was limitations in load balancing, for example, due to the fact that it was using IP tables with kubeproxy. So this was replaced with eBPF and XDP to have great performance. But there's inherent limitations in the fact that by default, containers use bridges to access the network bridge interfaces, and those bridge interfaces have there's a cost, there's a performance cost to using bridges. And so the idea of Netkit is to extend the kernel and provide a new interface that allows containers to have native interfaces with native performance. So with Netkit, now you have containers that have networking performance that is exactly the same baseline with the host. You don't see the difference. So this was introduced recently in Cilium. It's actually released. I don't know how many people will use it in production because it's still quite recent and requires a recent kernel. But again, I was surprised that TikTok is actually using it.
Yeah, that's interesting. So Netkit is one, and but sorry for the ignorance. Netkit is a project from Isovalent, or is it for other people and you use it to? Or is a component of the kernel?
So Netkit is a new abstraction in the kernel itself.
In the kernel, right? Okay.
It was provided by Isovalent and maybe other contributors. I'm not aware, but it's an evolution of the kernel and in the scope of evolving eBPF in the kernel.
Okay. Sorry, my ignorance on these things. I mean, if you don't follow things, you get lost.
Yeah. I know. That's crazy. Yeah.
I wouldn't say
other things in general is extending Cilium beyond cloud native, right? There's benefits of eBPF far beyond cloud native. That's kind of obvious. And so one thing where we've been pushing is using Cilium as a bridge between cloud native and non-cloud native workloads, what we've called Cilium mesh. And the idea is using Cilium as what we call a transit gateway between containerized resources in Kubernetes and resources that are in a VPC somewhere in a cloud. The idea is that you can, for example, expose the service cider from your Kubernetes cluster. You could typically expose the DNS server to have a service discovery. And then the problem is routing. And so as far as routing, you can use Cilium for routing, and Cilium will on one side control the routing on the Kubernetes side, and it can also be plugged to your cloud provider to control the routing in the cloud provider and pretty much attract the routes to the service cider inside a Kubernetes cluster. So provide a bridge between the two so that you can have VMs that talk to services inside Kubernetes using their DNS discovery name, and vice versa. You can have services in Kubernetes that talk to VMs using an internal service name in a transparent manner. So this is where we're at, is bridging the two worlds in a transparent way.
And how is the component part in, let's say, the non-Kubernetes world? What do you have? Some kind of standalone software kernel? How do you implement the Cilium?
So nothing really. Cilium works as a transit gateway. And so the idea is all that you need to do pretty much is provide the DNS resolution for services in Kubernetes. You can do this by exposing a DNS server from Kubernetes pretty much. And using it for your VMs, for example, in your environment. And the routing part can be done by Cilium as well, by attracting the traffic using VPC routes, for example.
Okay.
This can be done with VPC routes in the case of cloud providers, or it can be done with BGP, with on-prem. Cilium supports BGP, so you can already peer a Cilium-enabled cluster with BGP-enabled network, so underlying networks. And that means you can announce routes using Cilium. And at this point, you can announce services. That was the main use originally. It's to announce routes for pods. It's to announce services. So working as a public load balancer for the cluster. You can announce private services. You can announce egress gateway as well. So there's a lot of IPs that can be assigned by Cilium and then announced on the network using BGP.
Nice. So Cilium has been acquired by Cisco. When it happened?
So, I mean, not Cilium, but Isovalent was acquired by Cisco. It happened in, this is a big difference, right? Because Cilium, the Cilium project belongs to the CNCF and still belongs to the CNCF. We gave it away. So it doesn't actually belong to Isovalent. We're contributors.
Okay.
So Isovalent was acquired by Cisco in April. So it's been a bit over 6 months.
And Isovalent is based on where?
Geographically, we used to be based in Zurich and in California, and we're pretty much all over the place.
Okay. How many people work there in Isovalent?
It's hard to tell. Around 150, a bit more than that.
Okay. And what is the business? How do you? I mean, you contribute to Cilium, which you donated to the CMCF. So now, what happens?
That's always the good question in open source, right? How do you solve the open source problem?
Yeah.
So Isovalent has a product that is called Isovalent Enterprise, and it's based on Cilium and Hubble and Tetragon. So there's 3 open source projects actually, right? There's Cilium for networking, there's Hubble for observability, and Tetragon for runtime security, all based on eBPF. And so we have this distribution that is hardened and has extra features. Typically, the extra features are typical enterprise features, right? HA features, RBAC, stuff like this, reporting features, things that you probably won't need in your home lab if you use Cilium, but big companies will probably need. And so we have obviously a model where we sell this distribution and we provide support for it.
Okay. And the other projects you mentioned, the observability tool and the security tool, they are both from Isovalent as well.
Yeah, you mean Tetragon, right?
Tetragon and the other one.
Hubble. So Hubble Hubble allows to collect observability information from Cilium and from Tetragon, and to either access it on the CLI or in a UI. Tetragon is similar to Cilium in some ways. It is a controller that will generate a eBPF code, but it's more focused on security. So security observability and security enforcement as well.
Nice. And they are both open source?
Yes. In the scope of the Cilium product, yes.
Okay. Okay, so the evil question would be, what happens when some not customers, other people, other companies start to use these products for their own commercial products, and then you maybe want to change licensing terms or whatever.
No. Well, so there's several things in there, right? First, they already do. Google uses Cilium as part of GKE Data Plane v2, and they renamed it to ANETD so that people don't know that it's Cilium and they can change the implementation if they want to. So it's already happening. And second, this is not a problem anymore because we gave Cilium to the CNCF. So the Cilium project doesn't belong to us anymore.
Yeah. And what are the plans for Cisco in Isovalent? I mean, I guess some kind of integration with their products. Or,
so is your question what are our plans for Cisco, or what is Cisco's plans for us?
What are Cisco's plans? I don't know if your plans are relevant.
So surprisingly, and this is not a secret, you could think, hey, it makes sense for Cisco to acquire Isovalent because of Cilium, because Cisco is a networking company. The main reason why Cisco acquired us is actually Tetragon. So the security tool, and it's not a secret because a week after we were acquired, Cisco announced a project that is called Hypershield. It's a new product, and Hypershield, you can think of it as a distributed firewall based on eBPF. The idea is it's something that will analyze your data. It can be your flows. It can be the workloads that are running at different places in your infrastructure. And then based on this, it will detect security issues. This could be runtime security issues, CVEs, or it could be network security issues. And it will propose patches to solve these issues. And these patches are based on eBPF. And right now, the best way to generate these eBPF programs on the fly and apply them is using Tetragon. And so having Tetragon on every node to control every kernel and distributing the patches. Say, for example, hey, I found that this workload running on this machine, at some point it's going to use the kernel, right? So this workload on this machine has a security issue. There's a known CVE that if it accesses this directory, there's a problem. Instead of killing it like a typical endpoint protection tool would do, let's make it so in the kernel that it cannot read in this directory, and we just prevent it. We just return whenever the syscall is called, it will return an error and see if the program can survive this, right? But it's actually much more fine-grained than what traditional endpoint protection would do. So this is the main reason why Cisco acquired us, actually, is because they were already playing with Tetragon internally. Now, Cilium also makes a lot of sense. And obviously, there's integrations with Cilium that will be coming as well. And yeah, there'll be communication on this, because we will, for the end of this year, actually focus on communicating on how Cisco and Isovalent are getting along and collaborating.
Cool, interesting. So I would say let's move to more mundane matters. AI. What is your
That's
something we didn't we haven't heard in the last 2 years about AI. Tell us something new, if you can.
Oh my, there's so much to say about this. Who doesn't like glorified statistics, right? No, I've been using it tons. It's and just trying to think about it as well. It's useful for a lot of things. I saw a recent post by what's his name? I don't remember, this guy from Google, about how, you know, the iterations you have with AI can feel like more productivity sometimes, but it isn't necessarily. And I use it a lot, and I can get this frustration, right? So like after 5 minutes, you have something that works. Let's say like using AI for coding, right? Let's say using ChatGPT for coding. After 5 minutes, you have something that works, and then you have a specific use case you're trying to fix. The problem is that the code that was generated by AI is not the way you would have written it. So you're totally unable to debug it. So you're going to spend the next 3 days trying to tweak your prompt to solve it. And the AI prompt is not able to solve it. ChatGPT doesn't actually understand the problem. And when eventually it understands the problem and fixes it, it actually removes all the specificity that it allowed you to code before, because it like forgot, quote unquote, about the original project. And you end up with something that is fixed but doesn't do what you wanted. And so he had like this graph where you could see that, hey, it feels like, hey, I'm going really fast. Oh, but no, I'm losing time. Oh, but I'm going really fast, but now I'm losing time. And eventually what was really interesting is that towards the end, it looked like you're not actually reaching 100% like you would before, because in the past you would have finished your project entirely because you understand it fully. But now it's got to a point where what was produced is something you don't fully understand, and you'll never really finish it. And so I'm not saying this is bad, right? But I'm just saying I look around and I see these kinds of things. You know, I see advertisement when I go to the supermarket. I see ads that were done using Gen AI, where like in the past, they would have used a photographer. They would have, fine-grained or like retouched the image to make it look really nice. And now it looks unfinished. It looks like someone took 5 minutes to add the journey, you know? And nobody cares, because the person who did it doesn't know how to fix the image, right? This 6 fingers, but I don't know how to use Photoshop anyway, right? Because it's the wrong person doing it. And at this point, the photographer doesn't want to use Gen AI because they don't want to lose their job. So I don't know, at some point there'll be a convergence, there'll be something happening. But right now it's still, in a lot of cases, I think it's still very uncanny, right? Where you have people that all of a sudden, I can do something I couldn't do before. I can generate images I would not have been able to paint, but there's this weird thing in that image and I have no clue how to fix it. And Gen AI is not going to fix it for me.
Yeah, same as code, and maybe
same with code, same with a lot of things. Again, it's still pretty recent, right? But can it be solved? I don't know.
So one of the common things which is said about AI, and not only AI, and also other technologies, is that the impact in the short term is over-evaluated, and the long-term impact is under-evaluated. according to you, what could be is the typical question that if you know the answer, you become rich in a few years. What could be the applications of AI which we still don't know or don't really realize at the moment, but in some years will change full sectors of the way we do things and so on? Maybe not the specific. Yeah, I am asking, I'm gathering information for my next.
I clearly think the best use of AI is the one we don't talk about that much, right? It's like medical studies, physics, finally optimizing maybe the traffic lights in my town, things like that. It's the invisible things that you might not even realize are at some point powered or facilitated by AI, right? What is something that we're not even aware of? I don't know. And it all depends on what you call AI as well. I mean, these days, we think about AI, we mainly think about LLM-powered chatbots and Gen AI. And obviously, there's much more to it. And a lot of the things that will be most influential, I think, on our civilization are not these. I mean, this is really cool. Don't get me wrong, it's really cool. But
that's cool.
This is the part of statistics that will solve the biggest problem.
It's not only ChatGPT.
AI
world is not definitely.
Like cancer detection in an MRI image, ChatGPT is not going to solve that problem in a way that other models could solve it, right? And it's more important.
Yeah, indeed. So a common question I do in this, let's call it podcast, is do you know someone who I should invite in a next episode? Some person worth talking with?
Oh, my. I don't know. I have too many names.
More than one. There is not a limit.
No, I'd have a hard time giving you a name just right now. I'd have to think about it.
Okay, no names from Raphael. He gives no names. And last but not least, a question which I haven't asked, which you would have liked to be asked, and to which you want to reply to.
No.
About life, universe, and everything, IT, whatever.
Well, I am actually 42 this year.
Oh, that's an achievement.
Have the answer.
I have a secret to tell you. I thought everything was going to change in my life at 42. Nothing changed. But it depends. Maybe
something changed. Your number of years changed.
Okay, so I would say thank you very much, Raphael, for the discussion. Interesting things about eBPF, Cilium, and the, let's say, Kubernetes ecosystem. And I don't know when we will see and meet again, but I guess it will happen sometime.
Yeah.
Thank you and bye.
Thank you, Alessandro.